Hello, my name is Suraj Malik. I'm a student of Leeds Packet University. My student ID is 77468-313. This is the presentation of my MSc Advanced Engineering Management dissertation. Topic is investigating sensor health for additive based fault using covariance method analysis. Introduction of my topic. Additive based error sources are random errors that adversely affect the sensor and are difficult to ignore in real-time applications. These are small, consistent errors that shifts the sensor reading. Traditional method may miss them, especially in real-time systems. This project used covariance analysis, residual regressions, and PCA simulated in MATLAB. Research aim is used covariance analysis to check sensor health and detect additive-based fault of sensors, and objectives are to understand the covariance-based fault detections and where it can be applied for sensor networks, evaluated it on faulty sensor data, build a real-time, low-resource diagnostic methods that adheres to lean and agile framework. Firstly, what is an additive-based fault? A sensor gives a consistently wrong reading. It doesn't crash, but slowly gives misleading data, risky for autonomous vehicle, drones, and factories. Example: a temperature sensor always reading +2 degrees Celsius above actual temperature. So, why we used covariance analysis? Reasons: healthy sensor have predictable relationship between readings. Covariance measures how two sensor value changes together. A sudden changes in covariance, possible fault. Some advantages of this method is low cost, work in real time, no complex model or high precision power needed. In literature review, sensor health is monitored nowadays in modern and industrial system is maintain accuracy and reliability in the receiving sensor data. Covariance data Covariance-based fault detections have a crucial role to play in the identifications old sensor faults. Covariance metrics quantifying the degree of linear dependence between different sensor reading serves as a primary anomaly detection vehicles. Next is methodology. In this, I used MATLAB to simulated time series data, added artificial fault in sensors. Techniques used in study included covariance analysis, residual regressions, PCA principal component analysis. First, covariance analysis performed variations of standard detection that checked difference across the sensor to find out correlations. Sensor residual regressions was used to check observed and predicted sensor outputs, and higher deviations were an indication of probable faults. Third, the presence of variations was determined based on the fault-induced change in the principal components using PCA. Performance used by the metrics which are evaluated with precision, precisions, recall, false positives, detecting delay. In research outcomes, the additive base was artificially injected into the sensor network to access effectiveness combined diagnostic approaches to identify fault sensors. Covariance analysis was successfully in isolating abnormal variations from the normal variations, As a key results, precision around 93%, recall about 89%, low percentage of false positives. PCA helped detect fault faster. These achievements were supported by PCA, which identified changes in variance to achieve better differentiations between normal and faulty conditions of the sensors. System is suitable for real-time and unclosed system. In the conclusion of research, this hybrid method is accurate, fast, and cost-effective, worked well in IoT and smart systems, doesn't need extra hardware and complex machine learning, suitable for modern automated environments. The study helps to develop new diagnostic technologies for the smart system and presents efficient testing procedure for predicting possible failures of sensors in the system and providing their reliability in the conditions of contemporary automated systems. In last, ethics and acknowledgement for the research. There no real sensors or people were used, fully simulated data. Ethically standards from Leeds Packard University were followed. I would like to thank my supervisor for this guidance and engineering faculty for providing sufficient resource and research support. Thank you.